Hello everyone, myself Tanvi Patel, working as Assistant Professor in Computer Engineering Department in Mahatma Gandhi Institute of Technical Education and Research Center, Navsari. Subject is IoT and its applications and subject code is 3160716 and Unit 1 is Introduction to Internet of Things. So today we are going to study about IoT Stack. So first of all, what is IoT Stack? The first step to becoming an IoT product manager is to understand the 5 layers of the IoT technology stack. For better understanding and analyzing of IoT business and technology, this stack is being divided into 5 layers. These 5 layers are device hardware, device software, communication, cloud platform and cloud applications. So, to put this IoT technology stack in context, let's imagine that we are developing a product that monitors the health of a wind turbine. This product anticipates when the turbine needs maintenance, thereby saving millions of rupees in potential damage to the turbine and avoiding interruptions of services. This technology is commonly known as predictive maintenance. Now, let's use this example of wind turbine to describe in detail each of the layers of the IoT technology stack. So, the first one is device hardware. Device constitute the thing in the Internet of Things. Device act as the interface between the physical and the digital world. They can be the first layer of the IoT technology stack. So here the first thing to consider is whether your product is being connected device itself or your product is turning an existing device into a connecting device by adding instruments. Next is one of the main goal of your device is to collect data, that is hardware that collects data. So next you need to think about what data to be collected and therefore what device hardware you need to do that. So for simple data collection you just only need one sensor. For more and complex data collection you need many sensors and you need an industrial computer that houses a powerful processor, many sensors, local storage, a gateway, etc. things. In this layer of the IoT technology stack, it's essential to understand hardware parameters such as cost, size, ease of deployment, reliability, useful lifetime, etc. These are the parameters which should be necessarily be part of the hardware cost. Now, for example, for small devices like smartwatches, you may only have physical space for a system on a chip. For more demanding solution, you may need an embedded computer like Raspberry Pi, Arduino or BeagleBone boards. For critical computing needs, you need advanced industrial computers like compact RIO or PXI. All of these solutions have different requirements around cost, size, battery life, etc. So, the demand of the technology, whatever you are creating or whatever you are installing, that depends on how much the data you have collected and how much bigger or smaller the thing is. So we have taken the example of a wind turbine. So here in hardware, for our wind turbine monitoring product, we will need an accelerometer as the sensor to collect vibration data. If the vibration is outside a specific range, that means the wind turbine needs servicing. Since this is a heavy industrial application, we will probably need to use an industrial computer like compact RIO since it has enough computing power and already has integrated accelerometer. So it has an inbuilt integrated accelerometer. So we need an industrial computer compact like RIO for our wind turbine. Now next is the device software. The device software is the component that turns the device hardware into a smart device. Device software is the second layer of the IoT stack. Device software enables the concept of software defined hardware, meaning is that a particular hardware device can serve multiple applications depending on the embedded software it is running. Device software allows you to implement communication with the cloud or other local devices. You can perform real-time analytics, data acquisitions from your device sensors and even control your sensors from your device. So, this layer of the IoT technology stack is critical because it serves as the glue between the real world, that is the hardware, and your cloud applications. It will be up to you and your team to decide how much functionality you place here versus in the cloud. So here the device software layer is divided into two categories. First is the device operating system and the second one is the device application. In device operating system, the complexity of your IoT solution will determine the type of device operating system you need. Means which type of operating system will be used by you in your IoT solution, that depends upon you. And the next is device application. That is, device application runs on top of the edge operating system and provide the specific functionality for your IoT solution. So here the possibilities are endless. You can use many types of devices and you have many types of solutions. You can focus on data acquisition and streaming to the cloud, analytics, local control, etc. in your device application. Now, the next layer is communication. In communication, it refers to all the different ways your device will exchange information with the rest of the world. Communication are the third layer of the IoT stack. Depending on your industry, some people refer to this layer of the IoT technology stack as the connectivity layer. Communication include both the physical networks and the protocols you will use. It is true that the implementation of the communication layer is found in the device hardware and device software. So it is found in the both device hardware and the device software. So by selecting the right communication mechanism, it is critical part of your IoT product strategy. It will determine not only how you get data in it and out from the cloud by using the Wi-Fi or the LAN or the wireless LAN or 4G, 3G technology, but also how you communicate with third-party device in the same building. So, for the wind turbine monitoring example, the first inclination might be to connect the device to a local area network, but the wind farm might be in the middle of nowhere and all you have is a nearby cell phone tower. So, you will have to connect to the cloud via the cellular communication to communicate with your wind turbine or to gather data of the wind turbine. Now, the fourth layer is the cloud platform. The cloud platform is the backbone of your IoT solution. If you are familiar with managing software as a service, offering them, you are well aware of the role of this layer of the IoT technology stack. A cloud platform provides the infrastructure that supports this critical area. So, the critical areas are data collection and management, analytics, and the cloud APIs, that is application programming interfaces. So first is data collection and management. Here your smart device will stream information to the cloud. As you define the requirement of a solution, you need to have a good idea of the type and amount of data you will be collecting on a daily, monthly and yearly basis. One of the challenges of IoT application is that they can generate an enormous amount of data. You need to make sure that which type of data you want and which type of data you want to collect. Next is analytics. Analytics is one of the critical component of an IoT solution. By analytics, referring to the ability to crunch data, find parameters, perform forecast, integrate machine learning, etc. can be performed. It is the ability to find insights from your data and not the data alone that makes your solution valuable. Analytics can be as simple as data aggregation and displays or can be as elaborate as using machine learning or artificial intelligence. Next is cloud APIs. The IoT is all about connecting device and sharing data, which you can achieve by exposing APIs at either the cloud level or the device level. Cloud APIs allow your customers and partners to either interact with your device or to exchange data. Now, the last layer is the cloud application. This fifth layer of the IoT technology stack is the most easily understood. Your end user application are the part of the system that your customer will see and interact with. This application will most likely be web based and depending on your user needs. So the applications are web based and which are being dependent upon the user needs. The user needs change as the application changes. So when designing your end user application, it is very important to understand who is your user and what their primary goal of using your product. For our wind turbine monitoring, one possible application would be a web application used by wind farm operator working in a central control room. This application displays information and trends on the thousands of turbines that they manage and alert them when a particular turbine needs a service. So the operator can get their information in real time and dispatch the service team to perform prevention, maintenance, avoiding cost repairs and service interruption. So this was the IoT stack which has the 5 layers. Thank you.